All right, so problem number 1, negative 10 minus 2x equals negative 26. Jaden Asensio, what do I need to do first to both sides here? I need to add the 10. Oops, excuse me. Let's try that again. So we add the 10 to both sides. So then I have negative 2x equals negative 16. And then, Jaden, what do I do next? Divide both sides by the negative 2. And this is where I keep telling you, because again, as I finish grading the quiz, which it is all graded now, we are not cautious with our negative signs. We need to make sure that's a negative divided by a negative. So we should have x equals positive 8. All right, Melody, for number 3, x divided by 17 equals negative 5. What needs to be my first step? Okay, this says x divided by 17. What's the opposite of divide? I need to undo that. I need to multiply both sides by 17. And in this case, it's a one-step problem. So Melody, what is negative 5 times 17? Negative 85. Tristan, number 5. The quantity 2 plus x divided by 9 equals 1. What do I need to do first here? Right, this entire thing is a fraction, so I need to clear that denominator first. So I have 2 plus x equals 9. And then Tristan, what would I do next? Subtract 2 from both sides. So we should have gotten x equals 7. So again, I'm going to pause for a minute for 7, 9, and 11. And I will tell you, 7 and 9 are different than number 5. Number 5, the entire side was a fraction, so we multiplied first. 7 and 9 are handled differently. So again, I'm going to pause while you do 7, 9, and 11, and we will come back and go over those. All right, so number 7, we have x divided by 5 minus 10 equals negative 13. So Jenny, what do I need to do first to both sides here? Number 7. I need to add 10 to both sides. So that leaves me with x divided by 5 equals, and Jenny, what did you get for negative 13 plus 10? Negative 3. So I have x divided by 5 equals negative 3. So Jenny, what should I do next here? Multiply both sides by 5. So we end up with x equals negative 15. So again, be cautious when you're adding positives and negatives. I'm seeing a lot of silly mistakes there because we're just going too fast. All right, Anthony Arroyo, number 9. 12 equals 10 plus x divided by 9. What is my first step here? Subtract 10 from both sides. So 12 minus 10 is 2 equals x divided by 9. And Mr. Arroyo, what would I do next? Multiply both sides by 9. So I get 18 equals x, or x equals 18. They're the same thing. So again, we have to know when is it that we have to start off with the multiplication, and when do we start off with addition or subtraction? We have to understand the difference between problem 5 and problem 7 and 9. They are handled differently because of the way they are set up. All right, number 11, negative 17x equals negative 119. Cambria, what do I need to do first to both sides? Divide by what? I need to divide both sides by negative 17. And what did we get for an answer, Cambria? X equals 7. All right. Now, I'm just going to have you do 13 and 15 next if you haven't already. I want to save 17 and 19 to do together because those are those literal equations we worked on Friday. So I'm going to pause to make sure everyone has 13 and 15 completed. Again, you can work more odds than that, but I need 13 and 15 completed. So number 13, we have x divided by 16 equals 4. So Devaney, what do I need to do to both sides here? I need to multiply both sides by the 16. So Devaney, what is 4 times 16? So we get x equals 64. Travis, what about number 15? What do I need to do first? Yeah, I have a double negative here. I have x minus a negative 6. And remember, that's like saying negative 1. So we have to take the negative 1 times the negative 6. So this is really x plus 6 equals 2 because double negatives end up being positive, a negative times a negative. So now, Travis, what should I do to both sides? Subtract 6, and then what is 2 minus 6? We get x equals negative 4. Now, 17 and 19, those are those literal equations we worked on Friday. So on 17 and 19, both of them want you to solve for a. So on number 17, solve for a. So that's the variable we want by itself. Number 19, solve for a. So again, I'm going to pause. If you need to look back, remember we added those extra notes on page 14 in your packet. So if you need to refer back to those, I'm going to give you a few minutes to solve these two literal equations. All right, number 17, negative 3a minus 3m equals negative 1. Again, we're solving for a, so we're treating that second variable more like a number. We're going to move it with the number that's attached to it. So Erica, what would be the first step here if I'm solving for a? Add 3m to both sides. I need to move this. That m is going to stay with the 3, so I'm going to add 3m to both sides. So I have negative 3a equals, and you can either write it as negative 1 plus 3m, or you can rearrange it and say 3m minus 1. They're the same thing. And then Ethan, what would I need to do to both sides? Divide by negative 3. I need to move that negative 3 away. So I get a equals, I'm going to divide that negative into the numerator. So negative 3m plus 1 divided by 3. So again, we're trying, whatever variable they ask us to isolate, The other variable is treated more like a number in moving it. All right, Nayeli, for number 19, 3a minus 2k equals 5. What am I going to do first? Shh. We're going to start off by adding 2k to both sides. We're moving that entire expression together. So we get 3a equals 2k plus 5, or if you wrote it as 5 plus 2k, that is fine. And then Lila, what do I need to do next to both sides to get a by itself? I need to divide by 3. So a equals 2k plus 5 divided by 3, or again, if you have 5 plus 2k divided by 3, that is the same thing. It's just normally you'll see them writing the one with the variable before the constant. All right, so we've done now some literal equations. We've done some 1 and 2 step equations. Now starting with number 21, you're getting into the variable on both sides. So I'm going to pause while you complete 21, 23, 25. 21, 23, 25. On number 21, we have 3x minus 3x equals 5 minus 5x. Michael, what do I need to do first here on this problem? Okay, before I can plus the 5x, what do I have over here on this side? Yeah, I need to combine those like terms. So I have 3x minus 3x gives me 0 equals 5 minus 5x. We should always be looking, can I combine like terms before I start solving? Now I will add the 5x to both sides. So we have 5x equals 5. And then, Michael, what do I do? Divide both sides by 5. So we get x equals 1. But we should always be looking to see, can I combine like terms? What do I need to do? Because I need to combine those like terms first. All right, number 23, negative 1 times the quantity 4 minus x equals 3 times the quantity 3x minus 4. Lily, what is my first step here? Yeah, and on this side I have a negative 1 I have to distribute. Here I have a positive 3. So negative 1 times 4 is negative 4. Negative 1 times negative 1 is plus x. Equals 3 times 3x would be 9x. 3 times negative 4 would be negative 12. So after we distribute, we should have negative 4 plus x equals 9x minus 12. So Lily, what did you do next? Subtract 9x from both sides so we can get our variable on one side. So negative 4 minus 8x equals negative 12. Then what did you do? Add 4 to both sides. So we get negative 8x equals negative 12. And then what's the last step, Lily? Divide by negative, divide by negative 8. So what do we get for x? Now, if they don't ask us to round it to a decimal, we should be leaving this as a fraction. Oh, it's not negative 12. What's negative 12 plus 4? You guys let me put a bad number there. Negative 8. So what's negative 8 divided by negative 8? You guys got to let me know when I do bad math. All right, number 25. Jaden Buenabad, what is the first step I need to do on number 25? Yeah, I have to distribute a positive 2 on the left, a negative 7 on the right. So I should have 2x minus 2 equals negative 7x minus 49. This is where I say we have to pay attention to those signs. So Jaden, what would I do next here? What's the opposite of minus 7x? So we need to add 7x to both sides. Because I need to get that x on the same side. Oh, I didn't multiply 2. Thank you. Gosh, I'm not having a great day here, am I? 2x minus 4. Thank you. So now, when I add the 7x, I have 9x minus 4 equals negative 49. So what is my next step, Jaden? Add 4 to both sides. So we get 9x equals negative 45. And then that last thing, divide by 9, so we should get x equals negative 5. All right, so left in this solving multi-step equation section, we have number 27. So I'm going to pause for a moment while to make sure that we've got number 27 completed before we move on to our absolute value and our proportion questions. So make sure that you have number 27 completed. All right, so number 27, again, just finishing off this section, we do have to distribute, but only on one side this time. We have to distribute the 5 to the quantity 3 plus 4x. So we have 5 times 3 gives us 15, plus 5 times 4x is plus 20x, equals negative 36 plus 3x. And again, I can't say it enough, be cautious with your negative signs. Make sure we are carrying down the appropriate negative signs. We're doing the appropriate math. So now I need to move my variable to one side. So I'm going to subtract 3x from both sides. So I have 15 plus 17x equals negative 36. I'm going to rewrite that over here so I have room. Then I need to subtract 15 from both sides. So 17x equals negative 51. Again, they are both negative, which means I need to add them together and keep the negative sign. And then if I divide both sides by 17, I get x equals negative 3. So again, just take our time as we're solving these multi-step equations, making sure we're looking, is there combining like terms? Is there distributive property? Am I being careful with my negative signs so that I'm getting the correct answers? All things that we need to slow down a little and make sure that we are doing well. All right, we have two absolute value problems, 29 and 31. I'm going to pause for a minute to take a look and see how we're doing on getting these set up. So 29 and 31 right now. So with absolute value, what is the key that I need to remember with absolute value? What makes these problems different to solve than some of the others we've been doing so far? Because if we don't know the difference, then how do we set it up to solve? Yes, sir. Why do I have to make two different equations? But what about absolute value that causes me to make two different equations? What do I know about absolute value? It's a distance, which means that 11, when it was inside the absolute value, could have been a positive 11 or it could have been a negative 11. So I have to solve for both possibilities that would give me an absolute value of positive 11. And I do want to see two different equations. I do not want to see you working off of the absolute value because that's not how it's solved. So we have 9 plus 4x equals positive 11, or 9 plus 4x equals negative 11. And again, it's because absolute value is a distance or a measurement. What's inside could have started out positive or negative to give us that positive 11. So I'm going to start by subtracting 9 from both sides, which gives me 4x equals 2. Divide both sides by 4. X equals 2/4, which reduces down to 1/2. And I've had the question, do I leave it as a fraction or a decimal? Unless they ask you or give you information on how to round it, it should be left as a fraction. So we should be leaving that as 1/2. Then we have to turn around and solve the second one, which again starts by subtracting 9 from both sides. But this time we get 4x equals negative 20. Divide both sides by 4. And we get x equals negative 5. So my solution set is 1/2 comma negative 5. So I need to make sure my absolute value has two answers with it. Number 31, the absolute value of x divided by 2 equals 5. So we have x divided by 2 equals 5, or x divided by 2 equals negative 5. Here it's a one-step equation. It's x divided by 2, so I undo that with multiplication. That gives me x equals 10. Do the same thing to the second equation, and I get x equals negative 10. So my solution set here is 10 comma negative 10. All right, the last thing we learned about in the unit was proportions, and this is about cross products. Remember, we're doing that cross multiplication. I'm giving you a little visual there of how they set up. I'm going to pause for a moment while you do 33, 35, 37, and 39. Again, being cautious of positive and negative signs, and then we will go over them. All right, so again, on proportions, we are cross multiplying. We have to make sure if we are multiplying times an expression like x plus 3, when we set that up, that's going to be a distributive property because we have 4 times the quantity x plus 3 equals 10 times x. Anytime we have an expression, that's going to be a distributive property. So that's 4x plus 12 equals 10x. And could I move the variable to the right? Absolutely, since I already have the 10x over there. So I could subtract 4x from both sides and get 12 equals 6x. Divide both sides by 6 and get x equals 2. But again, it's about if there's an expression, we have to make sure we're distributing. Again, cross multiplying, so the 5 is going to multiply times the x plus 3. The 10 is going to multiply times the x plus 2. So 5 times the quantity x plus 3 equals 10 times the quantity x plus 2. Again, distributing. So that is 5x plus 15 equals 10x plus 20. Now that I distributed, I need the variable on one side, so I'm going to subtract 10x from both sides. Negative 5x plus 15 equals 20. Subtract 15 from both sides. Negative 5x equals 5. Divide by negative 5. And x equals negative 1. All right, number 37, again, cross products here. 4 times the quantity x plus 2, 8 times the quantity x plus 2. So we start off 4 times x minus 2 equals 8 times the quantity x plus 2. Now we have to distribute on both sides. So I have 4x minus 8 equals 8x plus 16. Again, I need the variable on one side, so I'm going to subtract 8x from both sides. Negative 4x minus 8 equals 16. Add 8 to both sides. Negative 4x equals 24. Divide by negative 4. And x equals negative 6. But again, the key to success is knowing we have to cross multiply, knowing that we have to distribute if there's an expression, and again, being cautious of our negative signs. Make sure we are completing the correct math. Number 39, again, we're going to start with those cross products. So I have 6 times 2 equals 3 times x. So 12 equals 3x. Then I have to go in and divide both sides by 3 and get 4 equals x. Or again, if you put that as x equals 4, it is the same thing. And last, we have our word problem here. The standard width of a high school basketball court is 50 feet. If 1 meter equals approximately 3.3 feet, what is the width of the basketball court in meters, rounded to the nearest tenth if necessary? So they're giving us right here this 1 meter is approximately 3.3 feet. That is a ratio. 1 meter to 3.3 feet. Whatever they list first is the numerator. Whatever they list second is the denominator. So they've given us that ratio or that scale that is used for the measurement. That 1 meter is approximately 3.3 feet. So what we need anytime we're setting up proportions, remember, we have to set them up in the same order. So if I'm doing meter over feet for one of the ratios, that means the second ratio also needs to be set up as meter over feet. So now I have one of my ratios here. This scale or this ratio, that's going to fill in. We're going to use that for one of those meters over feet. So 1 over 3.3 equals, now the only other measurement they gave me in the problem is the width is 50 feet. So is that 50 going to go in the numerator on the other side or in the denominator if we're talking about 50 feet? Why the denominator, Tristan? Yeah, we said feet are going to be in the denominator, so that 50 has to match with where the feet are, and they asked us to find the meters. That's why it goes in the numerator. And again, once we have our proportion set up, we're going to solve it by using our cross products. So 1 times 50 equals 3.3 times x, which means that 50 equals 3.3x. So we're going to divide by 3.3. Now, they also do tell me round to the nearest tenth if necessary. So when I do 50 divided by 3.3, I get 15.151515 and so on equals x. But they said the nearest tenth, which means I'm only going 1 decimal place. So in order to know what I do with that 1 decimal place, I need to look at the number behind it. What does that 5 tell me to do with the number? Does it tell me to leave it a 1 or bump it up to a 2? What does the 5 tell me? Am I going to leave the 1 as it is, or am I going to bump that 1 up to a 2? Yeah, anything 5 and above tells us we're going to bump up. So this would round to 15.2 equals x. But they didn't ask me to solve for x. They asked me what is the width of the basketball court in meters. So my answer, I need to say all of that. I can't just say x is 15.2. The width of the basketball court is 15.2 meters. Anytime we have a word problem, we need to make sure that we are answering in context of what they're asking. They didn't ask for X. They asked me for the width of the basketball court, so I need to make sure that my answer responds to their question. And yes, it should be in a complete sentence. That is the other part, is we do need to write incomplete sentences. So I know some of you, because we started this review yesterday, have already started working on the evens. Fine. You need to make sure, though, you finish working all those evens tonight. I will be posting a full answer key in Google Classroom this afternoon, so you can go back and double check. but you need to make sure you're practicing those problems to make sure you are ready.